Okay, so here's some more examples of solving exponential equations. So we're going to go through the same thing that we went through in part A to try to solve these equations. Now again, if you are looking at a single power on the left-hand side equal to a single power on the right-hand side, what you want to try to do is write one power with the same base as the other power. Okay, so I usually like to look at the larger base to see if there's any way for me to write this as the same base as the one that's on the other side. And so if I look at 729, I know that I can write 729 as a base with a base of 9. So I know that I can rewrite this as 9 to the exponent something. And so I'll leave the left-hand side the way it is. And I'll rewrite the right-hand side as 9 to the exponent. So let's do 9 to the exponent 2, I know is 81, so that's too small. So let's try 9 to the exponent 3. And I get exactly 729. So 9 to the exponent 3 is another way for me to write 729. And so now that the bases are the same, I didn't have to do too much work for this one. Since the bases are the same, then that means that the exponents have to be equal to each other. And in this case, setting the exponents equal to each other already gives me the answer, which is 3. Okay, we can do the same thing for the next one. Again, I have a power with a base of 2 on the left-hand side and a power with a base of 64 on the right-hand side. And I know that 64 I can rewrite with the base of 2. So I'm going to rewrite the right-hand side as 2 to the exponent. I believe it's 6. Yep. And so 2 to the exponent 6 gives me the same thing as 64. And again, since the bases are the same, then therefore I can set the exponents equal to each other. And if I rearrange to solve this, I get x is equal to 5. And again, you can check your work very quickly. If I plug in 5 into the left-hand side, I get 2 to the exponent 5 plus 1. That gives me 2 to the exponent 6, which is equal to 64. So I know I've done that one correctly. Okay, last example, same idea. Look at your two bases. This base has a value of 5. This base has a value of 25. I know I can rewrite 25 with a base of 5. So I know this will just be equal to 5 to the exponent 2. And the left-hand side stays the same. And then since the bases are the same, therefore the exponents must be equal to each other. And then I can rearrange to solve for the value of x. So if I add 2 to both sides, I get 3x equals 4. And so what that means is that x equals 4 over 3. And there you have it, some more examples of solving exponential equations. Okay, and so your assigned work is page 367 to 369 in your textbook, and you have a bunch of questions there. So be prepared to do that in class tomorrow, and then you're watching the video for lesson 2 tomorrow night for homework. Okay, that's it.